Hello students, my name is Sumit Mehta. So in today's lecture we will discuss about some properties of definite integrals. Okay, so I'm writing down the property number 0, which is a to b f of x dx is equal to same limits a to b f of t dt. So if I change the parameter of the integrand, there is no change in the value of the integrand. So the integrand remains the same. And the property number 1 is if a to b f of x dx is equals to minus b to a f of x dx. Okay. So let me give you the proof of this. Proof P1. Okay, so no requirement of proof of P0 because there is only change of parameter. Okay, now in this let f be the antiderivative of fx. So what I will get is f of x is equals to fx dx. Now by applying the limits from a to b, what I will get is fb minus fa. Okay, which I can simply write f of a minus f of b if I take negative sign common. So this will be equals to b to a fx dx. So simple, students. Okay, so this property always holds true. And the property number 2, P2, is a to b f of x dx is a to c f of x dx plus c to b fx dx. So this property is simply breaking down the integrand. I can show you from the graph. Let's say fx is a function and a to b integrand fx dx give us this area. Okay, so if I substitute, or if I take any point c in between, let's say this is x equal to a and this is x equal to b and this is our y is equals to fx. So if I take a point in between a to b such that, so this area will give us a to c fx, because this is the area under fx between the ordinates a to c, and this area, the right hand side area, will give us the b to c fx. Okay, so when we will add these two areas, we will get the area of the whole a to b fx dx. So I hope, students, that this is pretty clear from the graph itself. Now move to property number 3, which is a to b f of x dx is equals to a to b f of a plus b minus x dx. Okay, so students, the proof of this property is proof. So let's say let t is equals to a plus b minus x. So this is dt is equals to minus dx if we differentiate on both the sides. So when x equal to a, t is equals to b, putting the value of x equal to a in this, we'll get t equal to b, or when x equal to b, t will become a. So now I can write a to b f of x dx as minus b to a f of a plus b minus t dt. Okay, so this is a to b f of a plus b minus t dt. Okay, so from here I can f of a plus b minus x dx by p0. P0 is change of only the change of parameter, and this is by p1. Okay, so negative sign, which was f of x a to b dx is equals to minus b to a fx dx. Okay, students. So now I hope that you guys are pretty clear, and let's move to property number 4. Okay, we will discuss the rest 4 properties in our next lecture. Okay, so stay tuned for next lecture on continuation of the sum properties of definite integrals. Thank you. Happy learning.